when I think about people, I kind of feel like we're all in this together. We got one planet. We got one kind of arc of technological progress that's happened over time. We have lots of different ways that people live, but technology certainly can affect a very broad subset of the population. In order to do anything useful with data, you have to understand what the data mean. You have to understand what the measurements represent, why they were collected, what process collected them, and what kind of changes to the data were introduced because of that process. So whether you're doing, a natural science application or a public health application, you really do need to have that context about like what the numbers mean in order to make any kind of conclusions at all.
Hello, and welcome back to Tomato Tomato. I'm your host, Talia Sherman, and I want to take a moment to address the obvious. On December 13th, 2025, there was a mass shooting at Brown University. I was on campus, I was in lockdown, I was safe, and then I was really, really sad for weeks. This interview was recorded in advance of the shooting, and unlike my current mental state, it's not sad or depressed or pessimistic. On the contrary, John DeNero is full of optimism. He believes that education is critical for benevolent applications and deployments of technology. He's full of hope for the future and excitement at the prospect of educating the next generation to do better things with data. While I could not have foreseen what happened in between the time of this interview and the time of this episode's release, I don't think there's a better sentiment to feel right now than optimism, or a better person to discuss progress in education with than John. For a little more context, I'm a senior. Throughout the fall semester, I only met and befriended a handful of freshmen. And it was one of those freshmen who passed away because of gun violence. I don't want this to be dark. There's enough darkness in the world between a 14-hour lockdown, a mass shooting, and the broader political context framing and coursing through 2026. And yet, despite all natural inclinations, I am more interested in feeling overwhelming positivity and gratitude than being pessimistic. Enter John DeNero, Faculty Director of Data Science Undergraduate Studies and Associate Teaching Professor in the Electrical Engineering and Computer Science Department at Berkeley. John is the best, and this episode was an absolute delight to record and produce. There are many things that I could highlight about this episode, but I want to hone in on just one thing. Many people talk about the ethical imperative of understanding data in context. They talk about the ethical imperative to really understand the populations that we're creating technology for, to understand why and for whom this technology gets developed and deployed. John won't talk about this ethical tension at all. Instead, he'll highlight a structural imperative of understanding data in context. To me, this shift sets him apart from a lot of other human-computer interaction and machine translation researchers, and I encourage you to think about this shift alongside other disciplines. So think about what a shift from an ethical imperative to a structural one would look like in anthropological or sociological or linguistic research. In other words, I think John is alluding to the question of, what if you set aside ethics, which is broad and nebulous and also culturally relative and determined, and instead thought about the effectiveness, the efficiency, or the structural accuracy of your technology as your evaluation criteria. And maybe, just maybe, if you prioritize the structural imperative, you might find that your technology ends up being far more ethical than if you had prioritized the ethical imperative in the first place. So with that, welcome back into your ears, John DeNero. John DeNero, welcome to Tomato Tomato. I'm so happy to have you here today.
Thank you so much. I am delighted to be here.
Yay. Okay, so first, can you introduce yourself? Who are you? What do you do? Where are you doing it? I will spoil some things. I'll say that you're a computer scientist at Berkeley, but you've also worked at Google Translate, and you used to study both philosophy and linguistics at both Stanford and Berkeley.
All true. Yes, I am a teaching professor in the Electrical Engineering Computer Sciences department at Berkeley. And then I am also director of the data science undergraduate program there. So you add all that up together, and most of my time now is spent on teaching undergraduates and organizing the courses and degree programs that they do. Which is really fun. It's just a lot of collaboration with other faculty to figure out how to deliver a great experience for students. I also do a fair amount of research, and my research arc has changed over time. So I started out just focused on building the technology behind Google Translate. I didn't build it all myself, of course, but I did contribute to that for several years. And my PhD was on machine translation, which is the kind of problem of translating automatically from one language to another. But I have now strayed into a fair amount of human-computer interaction, because now this technology actually does something useful. In translation, it did already when I got started in the field, but the fact that machines can automatically translate languages wasn't really true when I got started back in 2005. There was something useful coming out, but not very good, and it was always easier to make fun of it than to use it. But now in 2025, we have a technology that really does translate quite reliably in different settings. So that's pretty exciting. Now we have to think about how people are going to interact with it. How are they going to use it in order to get something done? So I do that for translation. I do that also in the education setting now, where I think a lot about how students can use artificial intelligence tools in order to learn more or learn more efficiently. And that's been a pretty fun adventure, because then the teaching part of my life and the natural language processing background have come together into some really nice projects.
Keep going, yeah.
I can keep going if you want. Yeah,
please, yeah.
I guess the direction in which this mixture of human-computer interaction and automatic translation has gone is that I co-founded and am chief scientist at a company called Lilt, and we are just trying to figure out how to make sure that the AI and translation technologies that exist today are actually as useful as possible for professional translators. So people that are trying to get the translations just right for publication, and that means that you have to have a lot of human care, but also a lot of useful tools at the same time.
This is all fascinating, and I just want to ask about everything all at once, but it's helpful to take it in pieces, I think. But let's start with, you're the faculty director of data science undergraduate studies at Berkeley. And I think that anyone with a half a brain cell to a full brain cell and a minute to look you up will see immediately that you care deeply about pedagogy and teaching and course construction and innovation within course construction. And sort of among other things, you created the largest undergraduate course at Berkeley, the Foundations of Data Science course. And as a grad student at Berkeley, you also taught the only undergraduate course in artificial intelligence. So you have been at the forefront, or at least a pioneer of this in many ways. And when you talk about data science and the importance of education in data science, you emphasize interdisciplinary inquiry for sure, but also the importance of understanding the data in context, not just being able to do things with data and do statistics on it, but also understand it in context. Can you talk a little bit about what that's like? Why you care so much about data science, and what's going on there with making the largest course at Berkeley? You clearly care deeply about rising out on top in a very competitive major market that is Berkeley undergrad, I'm sure.
Oh, sure. I mean, I think I've always been motivated by trying to build the courses and programs that I would have wanted to take when I was an undergraduate. And data science at Berkeley brings together people from lots of different departments. But the story is that when we looked at how data was being used at the kind of graduate and research level, we saw a lot of interdisciplinary work. People were doing statistics, but with computing and with domain experts that were telling them what the numbers mean. And you need all those ingredients together in order to understand anything interesting about the world with data. So the way in which undergraduate teaching was done, I mean, it varied. There was a lot of great other work, but what was happening at Berkeley didn't try to meld computation, statistical analysis, and domain expertise all at the same time. And you need them all in order to get something done, because computers are a wonderful tool for managing data and for running simulations and things like that. The statistical perspective gives you this sense that you never see the whole picture. You only have the data that is kind of a sample or a snapshot of the phenomenon you want to study. And the real underlying thing in the world that you want to study is always something that's more complete or more extensive than what you can see through the data. But the interesting part, and I think something that sort of relates to linguistics, is that in order to do anything useful with data, you have to understand what the data mean. You have to understand what the measurements represent, why they were collected, what process collected them, and what kind of changes to the data were introduced because of that process. So whether you're doing, a natural science application or a public health application, or trying to understand, how students behave in the classroom, you really do need to to have that context about like what the numbers mean in order to make any kind of conclusions at all. So yeah, that was kind of the motivation for creating a new data science program at Berkeley, was to make sure that students saw all these pieces together right away, understood that they were connected and that you can't just pick one or the other and call it a day if you want to learn something interesting about the world. So I guess like what's my approach there? I just want to make sure that education is useful to students. I want to show them that it's interesting and powerful to use computational techniques, statistical techniques, but also to make sure that they go and apply it in a way that actually gets it right, draws the right conclusions at the end of the day.
And you said that relates to linguistics. How does that relate to linguistics in terms of understanding your data in context?
I think the amazing thing about language is that words don't mean much in isolation. Meaning comes from the context in which words are used. And the same sentence can mean different things in different contexts. And somehow humans are just comfortable with this. We're all users of language, and we're all ready to interpret different sentences in different contexts in different ways. That's how we operate. But translating that skill, which is a very human ability, into something that's less natural, which is working with data and computation, is not something that all humans are just ready to do based on childhood. They need education and practice to do it. So I just want to make sure that the ability of people to think about the context in order to do an interpretation of something isn't just how they understand language, but also how they understand data sets.
Okay. And so when I was working on doing my research to prep for this interview, I had originally, as I was telling you, like gone through your research and was sort of doing my usual thing. And then I realized that a lot of your work and your approach and your process in teaching is very similar to your work and approach and process as someone at Google Translate and as a researcher. So at Google Translate, working with both machine translation, but then also neural network methods, you care about the data that you're choosing from. You care about understanding that data in context, obviously, because you want to translate correctly. That has tremendous consequences. And then also you're incredibly sensitive to the product that you're creating and whether people are going to use it. Google Translate being used by billions of people, an undergraduate course at Berkeley being taken by thousands of students, things like that. Transitioning over to talking about your work at Google and at Lilt and everything like that and working with AI, what are the similarities, differences between your process and approach to teaching and then also to working on machine translation?
I joined Google Translate right after graduate school, even though I was pretty sure I wanted to be a professor one day, because the timing was just so good. Google Translate was suddenly a natural language processing tool being used by 100 million people a month, which was at a scale that no other language application had reached at the time. Siri didn't exist, and none of these large language models were even really on the horizon when I got involved. And I think the thing that is true about everything I've done in my career is that I wanted to have a positive impact on lots of human beings. Like I like working on stuff that feels like it matters and is applicable and practical. Google Translate was a system that was built at Google because Google was already collecting all of the text on the web for their search engine. And so they had that available, and they could leverage that in order to build a translation system as well. But all of the text on the web includes a ridiculous variety of stuff that is sometimes beautifully written and sometimes is total nonsense, sometimes is factual and sometimes is not factual at all and is just people's opinions. And all of that was collected together into a data set that did accurately describe how people use language, but didn't always accurately describe how we would like text to be translated. So just the simple task of let's just replicate the translations that exist in the world in our machine translation system wasn't the full answer to how to build a good version of Google Translate. Yeah, you had to think a lot about the data. And I guess I was an unusual one in the Google Translate team because I didn't speak a lot of languages. And I didn't have like some moment in my life where translation had been transformative and made me want to work there. Instead, I was there because I really liked the idea of building something that would, bring people together, reduce the divide between different countries, and be useful to a lot of people. And so I ended up, as a researcher, looking a lot at what people actually asked for in Google Translate, like what they were trying to translate. Whereas I think most of the team was focused on what example translations exist on the web and trying to capture those and learn as much as we could. I was pretty interested in, what do people actually use this for? So that was a data investigation that taught me that a lot of people use it for writing love letters in one language and translating it to the other. But also a lot of people were using it to try to just look up like short words and phrases instead of using the full context of the document that is kind of what you'd expect. I mean, if you really want to translate something correctly, and you talk to a translator, they'll tell you that knowing how this sentence fits into the larger document is probably the most important thing, because otherwise you can't translate it correctly. You need that context. And yet, the humans that were using it were trying to do the fastest thing possible, which was copy paste a little phrase into Google Translate and see what comes out. But that's a difficult task to translate a phrase without its context. And that kind of thing inspired a whole line of work. Google Translate at the time would just kind of show a bunch of options of how it might be translated for an individual word. Ended up working on a project to update that to show like which are common translations and it helped people disambiguate between the different translations of a particular word. Because you type in post and translate that into Spanish. There's a lot of different ways that post gets translated. Is this a verb? Is this a noun? Which kind of post are you talking about? So we tried to give a display that would tell you all about that so that you'd have a chance of understanding which translation you were looking for. And that was very much sort of a user-driven project. It wasn't just the pure science of how you translate, but also was, how can people actually get some benefit out of this system based on the data that we can collect?
And okay, I'm sorry, I want to pick up on the love letters thing and then the short phrases. Is that selection bias? Like, do we figure out why? I understand that like we want to translate some like small word or something like that. Feels like that's just very common in terms of like user need. But why love letters?
Oh, I think that people were interacting with people all around the world online. That's still true today, but it was certainly true in 2010 when I joined Google. And when you're talking to people on online forums or video games or anything like that, oftentimes you encounter people who don't speak your language, but you want to talk to them. And sometimes what you want to say is something a little flirtatious, and Google Translate was the mediator of that. How do you say something nice about somebody without being able to put it in their language? I think, this is just a fact about language that people want to be addressed and communicated with in the language that they're most comfortable in. And at the same time, humans from all over the world want to interact with each other. Like they don't want to just talk to people who only speak their language. So translation technology is important for bringing people together.
And at Google, I know that you joined at a time when there was definitely a transition from using more statistical methods in machine translation towards using recurrent neural network models. You don't have to get super into the weeds of like the nitty-gritty between neural nets and machine translation, but just the implications of that or where you see those two different methods being used most advantageously when thinking about translating languages.
Sure. Before neural network approaches really started to scale up, we were using statistical approaches that were based on just seeing how often phrases co-occur. So you see a phrase in English, you see a phrase in Spanish in the same sentence over and over again, then that's a signal that the Spanish phrase is a translation of this English phrase. It's a little more sophisticated than that, but really that was the underlying idea, was that you could translate a sentence by breaking it up into phrases, translating each of those phrases based on statistics that had been collected over the whole web, and then glue those phrases together into a coherent translation. This is not how this doesn't work. I mean, I think it got us really far. It was wonderful to build a system that 100 million people wanted to use, even though it was regularly making errors. And still the system today makes errors, but not of the same kind that we saw before. And the reason that we couldn't really make breakthroughs in that framework of chop up the sentence, translate each part, and glue them together is that you can't understand what a phrase really means without the context of the full sentence, or preferably the whole document that it's in. And the big breakthrough with neural networks was that it allowed us to relax this constraint of just translating a phrase at a time and always think about the meaning of every word in the context of the whole sentence that it's in. And then you get a much better sense of how to translate this word because you can see all the other words that are around it. Yeah, so the neural network approaches were clearly superior in that they allowed us to make a guess about how to translate each part that actually used the full context of the sentence and later the document. But the technology, like the computing technology to make it work, just wasn't there until it was. So the transition happened pretty rapidly, but after I had left. So I was at Google until 2014. We were already building neural network-based prototypes, but they just couldn't scale up to the length of sentences we were getting in. We just didn't quite know how to handle full documents or full sentences yet. By the time I had left and a few years had gone by, the technology had improved, and all of a sudden we could build a fully neural system, and that's what you use at Google Translate today. So they've retired the system that I worked on that didn't have neural networks at the center, and I think that's a good thing. I think it's great to think about language and words and phrases as having meaning because of the context that they're in, and that's exactly what neural networks can do.
That's awesome. Is that so? Can you talk a little about your work at Lilt? I mean, I kind of find this fascinating. So you co-founded, and now you're the chief scientist.
Scientist, I think, is my title.
You're the chief scientist. You think that's your title? Okay, at Lilt. And so, yeah, what's the product you're creating there? Like, how does that relate? What's going on? I mean, it's more AI focused, and obviously we're in a very AI hype moment. And of course, you and I both actually do a lot of work with AI. So, yeah, feel free to save space.
Oh, look, the interesting thing about Google Translate was that people loved it for trying to talk to somebody online or for doing their Spanish homework. But professional translators, while I was there, were not finding it to be a terribly useful tool. And the professional translators need to think about not only kind of translating things right, translating things fluently, but also using context beyond just the sentence or the document they're looking at. They know what the purpose of this document is. So they've talked to companies trying to translate a bunch of travel guides around the world. They've talked to the folks at the company that wrote the travel guides, and they understand that the goal was in order to get people excited about traveling to that place. That kind of context just isn't in a system like Google Translate. And so the right way to translate something for publication usually involves some of that additional context of what the purpose of the document is. Okay, so to get very practical, translators don't want to use a system that keeps making the same mistakes over and over again. So Lilt had to think about that. And then translators also don't want to use a system that has no hope of understanding or relying on that context of like, what's the purpose of these documents that we're translating? How are they going to be used? So we just wanted to build a system that was great for professional translators. That's, I think, what we did. And it allows people to translate accurately and quickly. And therefore, the translators want to use it. And the companies that need stuff to be translated partner with us. And again, it's had a big social impact. I think the access to information is a really valuable thing in our society. So Lilt gets involved when the translations have to be right. And that's things like the National Weather Service uses us in order to translate their alerts about weather events. And, they started doing this basically because without translating it, people's lives were at risk during Hurricane Katrina. And so they realized, we actually need to broadcast this information in lots of different languages that are right for the communities that need to hear it. So this kind of stuff, it's fun to keep working on things that matter. But also it's fun to think about someone who's a really highly trained professional, a professional linguist, and how can you build an AI tool that's actually useful to them? They don't need an AI tool. They could just translate the thing by themselves. but they would like something that makes their work faster, more accurate, that kind of takes the drudgery out of it. And if we can build that kind of thing, then I feel like we're building the right kind of AI, not to, replace people or do a worse version faster, but instead to help the people that are actually doing something well, do it even better or get more done.
Yeah, okay. So I want to push on this AI thing because I think it's important to think about it. So a lot of people critique large language models and AI saying like they're not real producers of language because it's just like statistical distribution of words and blah, 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 and it can't really have meaning. And what I say to that is like, yes, and, and look at what it's doing and look at the effects. Can you talk a little bit more about like how you see AI as useful and in what context? I know that you have spoken before about the importance of teaching students how and when to use AI and how it can be incredibly powerful and transformative in accelerating education. But then also, when you're thinking about building systems and products that are useful to professionals as well as to the layperson.
Okay, I'll answer your question, then I'll answer a different question too. So the current state of large language models is that they do some things well and they do some things poorly. That's kind of what we would expect from a new and emerging technology that's quite different from how humans were trained, is that they'll do some things that are great and some things that aren't. Certainly they're more responsive and they're available all the time. So when you think about education or machine translation for consumers, that's really important, is that you can have something that you can interact with whenever you want and as much as you want. The question of whether these are useful or not, like whether we should be using large language models in either education or in translation, I think is not a deeply philosophical one, but instead a kind of pragmatic question of whether we can see positive benefit that strongly outweighs any downsides. So in education, I think the net effect of large language models has been negative on the world just because it allows people to do homework assignments in ways that they don't learn as much as they used to. That just like unleashing ChatGPT on the world as a homework assistance tool has slowed down the pace at which people learn. That I can't prove to you because it's a global phenomenon, but based on talking to a lot of instructors, it's the case that this technology has, even though it's like made things easier in lots of ways, it's not really helpful for education broadly because students don't always use it in a way that's as constructive as possible. Even though that's the case, we can start to figure out how to use this technology in ways that do benefit students. So that's what my research and practice is really about, is how do we shift students away from the temptation to just look up the answer in the large language model and instead use it in a way that's much more like talking to a human tutor, where the tutor would not tell you the answer, but they would tell you where to focus, what to think about, what to go back and read so that you can get it right yourself. So we built some tools like this for introductory computer science. This worked really well. Students are happy to use a tool that helps them, even if it doesn't give them the answer, as long as it makes them feel like they're still making progress toward the answer. And if they want to learn, of course, that's why students are there in school. Of course, some of them are there because they have to be, but by and large, they want to learn. And so if you reshape the AI tools to be a little bit more of a partnership with the student in order to learn the material instead of tool that tells them answers, then all of a sudden it goes from being a hindrance to education to something that benefits education. Now, have we nailed this yet? I would say no. Like, it's still in process. This is a new technology, but I'm really hopeful that in the end, AI could help improve the educational process quite a bit. And, a similar story is true for translators. If the plan is to just translate everything with a generic translation engine like Google Translate, which is a great thing, but it doesn't capture all that context, and then ask a human to just clean it up really quick, but they don't really get to think through how it should be translated correctly, then what you'll end up with is something that's inferior to what you would have gotten if you didn't have AI at all. And that is the worst way to use AI, is to have it be part of a process that actually degrades the final quality. So instead, we have to come up with a way to use it that actually leads to higher final quality and also benefits the people that are using it by making the whole thing kind of more efficient. But I want to talk about something else,
Yeah.
too, which is, you said, do large language models understand the meaning of anything?
Oh, that's not my question. I think that's a question of many skeptical academics. Please answer, but that, I guess I definitely agree with you that the interesting question is not the philosophical one, but rather the pragmatic one. Because people have argued for years, for decades, for centuries about what language is or what meaning is. So the fact that we'll then be able to answer that question also when AI comes into the picture, is this language? We don't even know what language is, but does the LLM? I think that's kind of a non-starter. But yes, continue. Yeah.
Yeah, I totally agree with you when you're wondering, do large language models know what the text means that they're processing? Now all of a sudden you're just focusing on what you mean by the word meaning, and that's going to be a debate that lasts probably for all of humanity. I look forward to continuing to talk about it forever. But I do know that the structure of the models and their ability to take in a lot of context in order to figure out what to do next has a good property. A property that wasn't there before when we were trying to build language models and translation systems without neural networks. So at least we've taken an important step toward these systems understanding or having a representation of the meaning of the text, as opposed to just, shuffling words around or looking for co-occurrences.
You did a lot of work at undergrad on linguistics at Stanford. You did a lot of theoretical linguistic stuff, and then you actually have a master's in philosophy, mostly all doing analytical philosophy. So did you find that your background in linguistic philosophy mattered or still continue to matter when you're working on these language translation products? But if not, are there other ways in which that background or the methods that you gained influence you?
I think that the details of linguistic theories that I learned while I was an undergraduate probably don't influence my work a lot, but the approach to understanding language by trying to write down how it works and to search for counterexamples and to study particular phenomena closely absolutely aligns with the kind of detailed work that's required in AI today. So that's great. I also teach computer science, and so I talk a lot about programming languages, and it's always more accessible to students to understand how programming languages are the same or different from natural languages. And so my knowing a little bit about natural language has been great for just sharing a little bit of that with students, because that makes the subject, I think, more relatable. In philosophy, I would say the biggest impact on my life is just the approach that philosophers take to argumentation, which is that you can't form an argument about something until you understand and prove that you understand the thing that you're arguing against. And this approach that philosophers have taken for centuries and was taught to me as an undergraduate is exactly the right way for people who don't agree on something to make progress, is to first be able to describe what somebody else thinks and then start to critique it. So I love that. I also I think that having spent some time trying to describe what we mean by meaning or what we mean by reference in language, which is an area that philosophers ponder quite a bit, has always instilled in me this sense of wonder that we're able to use language even though it's so hard to describe how it works, and also a sense that there are a lot of details and complexities to manage anytime you're trying to build a computer system that works with language. And so we're not going to come up with something that is simple and interpretable that works as well as the large language models we have today, because we're trying to build systems that do interesting work with language and its meaning. And language and its meaning is just a fundamentally very complex thing. And so there's always going to be a fairly complex computational approach in order to make progress there.
I think that's interesting. I mean, you totally could apply that as like a metaphor. The philosophical framing as a kind of metaphor for how you approach at least some of the problems that you wrote papers on at Google, like one of them being how do we get semantically accurate translated from Arabic to English or vice versa output to also be morphosyntactically aligned. And thinking about, like, can you actually, first you have to really understand what it is you're trying to get to, point A or point B, whichever language, and like how how there is morphosyntactical semantic interface. And then like actually understanding the computation to get there. Multiple steps.
Yeah, totally. I mean, I think when I was at Google Translate, a lot of my projects were trying to work around the fact that we were breaking up sentences into pieces and translating them and then stitching that back together. And that this always got it wrong, whether that was because the syntactic structure of Japanese didn't carry over into English, or because English into Arabic would not have morphosyntactic agreement in the output. These were all kind of long-range phenomena where our fundamental method just wasn't set up to handle those well. And so we were trying to correct the errors. And we made progress correcting the errors by bolting on additional kind of layers of complexity. But the truth is that that approach was always going to plateau at something that didn't really solve the problem, because what we needed was a new approach to translation that would always take the full context of the sentence instead of just part of it whenever you're translating anything. And that, neural networks allowed us to do that in a fully kind of computational way. So we didn't have to think so much about why it was getting things wrong, but instead just let the system learn from examples in a way that we weren't kind of hobbling it or limiting its capacity to represent long-range phenomena, like the kind of stuff that I worked on.
I know that, so the course you teach at Berkeley, the largest undergraduate course at Berkeley, again, I think that's really cool, but it's a lot of your materials for that course are like available to the public, and you think a lot about that. And so I was wondering if you could talk about sort of how you see data science really influencing industry and products and work that we do that benefits and affects everyone. And then also just in general, like, do you feel like it's your responsibility that you do things that matter for everyone, not just internal to academia, or is that just something that you particularly are interested in?
I think that the point of education is to prepare people to make contributions to the world. When they go out in the world, they, first of all, should have the flexibility to work on the problems that they care about. And second of all, that they should actually make progress on them. Okay, so that's super broad, of course, but I think it is an inspiration for the teaching I've done in data science and in computer science, which is that I want to build courses that set people up to understand all the different ways in which what they're learning is applicable, and also like actually solve problems well. And we do a lot of problem solving training in these courses where we look at things where, you could interpret the answer in multiple different ways, but only one of them is right. And if you get it wrong, then you're going to make the wrong decision. And this is true when you're building programs in computer science. It's true when you're making decisions in data science. When I create something that seems to resonate with students at Berkeley, then I think it makes a lot of sense to share that out. Because when I think about people, I kind of feel like we're all in this together. We got one planet, we got one kind of arc of technological progress that's happened over time. We have lots of different ways that people live, but technology certainly can affect a very broad subset of the population. And so can some of these data science insights or systems that we put into place. So the algorithms that control what we see and how our attention is spent online affects just huge subsets of the world population. So in that sense, since we're studying something that has broad effects, it would be good if we make progress in education to share that broadly as well, so that everybody working on it does a better job. One of my favorite classes I've taught is the social implications of computing, which is a course really about the ethics of building computer technology. And I spent a lot of time just showing people how technology has changed the world and how broadly it has, and then ask students to think about whether it was a good idea and how the process could have been improved, because there's lots of negative examples of releasing technology on the world and having it do harm. And, I tell students, like, my goal is to train you to be very effective developers of technology, but also that gives you the power to change the world. I would rather you not screw it up. And I think that making good ethical decisions is only part of doing a good job at improving the world. Another part is to build software that actually works well and to make data-driven decisions that are actually correct. I think people with good intentions sometimes cause chaos in the world because they just don't do their technical work very well. So that I think all fits together in my grand plan to, help the whole enterprise of academia, which is to try to improve the way people can get stuff done in the world after they leave.
Mainly what I take from that is that, obviously theoretically nothing is theory neutral. But genuinely, that's a debatable position. Like, many people disagree. They think that the purpose of education isn't necessarily to shape people to do better things or make an impact or actually engage with the world. So you come from a base assumption that that's what education is for, but then thinking about all the ways to do that best. And it sounds to me like it's a combination of synthesizing technological acumen, but then also, as you said before, like domain expertise, and then really understanding your data in context. And that's a very different answer than I would get from someone else in a different field. So I think that's kind of fascinating that's how you approach it.
A totally reasonable, different perspective is that the purpose of academia is to seek the truth and to understand the world we live in and the people that we are. I support that. Like, a lot of the academic enterprise, especially its research efforts, is around that. But it's the case that only a very small subset of our undergraduate population at Berkeley is going to end up as researchers seeking the truth about natural science or social science or the humanities or something like that. Many of them are going to be builders, part of organizations that are trying to build, whether it's products or software or decisions or, banks or all the different kinds of things that we have in our society. And so I do think, for undergraduate education, we need to support both goals.
Right. And I think also some people would say that it's just to make money. So that's probably the third option. There's for pure enrichment and truth-seeking, for tangible impact, and purely for capital gains.
Yeah, the thing that it took me a while to understand about money is that it's just a reflection of progress, productivity, and contributions to the world. Now, the way money is allocated is not that, the way money is allocated is due to deals and financiers and all of this nonsense. But the big trends about, how much wealth there is in the world is very much related to whether people are building useful things. And the reason that software engineers got paid so much for so long is because the systems they were building were used by hundreds of millions or billions of people, and sometimes in a way that was actually improving their lives. So, making money is definitely related to the amount of impact that you have in the world. Now, there's people who, I try to make a lot of impact, but I don't focus on making as much money as possible. And there's people who don't really care about their impact at all, but just want as much money as possible. But most people are somewhere in between those extremes. They want to have a positive benefit on society and get paid for it. And I think that's a great way to approach life. And and setting up students to do exactly that is a good thing.
Thank you for that. Okay.
That was kind of a professorial answer, wasn't it?
Oh, absolutely. Well, I mean, you are a professor. Who are you if not professorial? So, John DeNero, I think that you need a little more than half a brain cell to figure this one out. But if you've ever talked to you in person or something like that, which I have, you'll know that you're a really funny person. You're just a really funny guy, and that's your vibe. Humor. Does that matter at all in the work you do? Where did that come from? Obviously that's a really hard question and typically a pretty traumatic, sad answer. Funny people tend to, that's a statistic actually. Comedians typically have really hard childhoods. That's whatever. We'll leave that aside. But just in general, you really are a very funny person. And I was wondering if you could if you could speak to that at all.
Yeah, that's funny, isn't it? I love life. What can I say? Like, why not have fun while you're doing things? The best part about being an academic is the people you get to hang out with, and yeah, you might as well enjoy doing it. The best thing I get to do these days is try to learn what undergrads think are funny now, because they're much closer to my 9-year-old than they are to me in their age. And I won't claim that they all behave like 9-year-olds, but it's like, but they have a youthful spirit that I have aged out of. So, so then I grill them on like, what the heck does dab it up mean? Or why do you keep saying 6-7 over and over again? And having them explain that to me, first of all, it's like great example of language change. Okay, that's rad. We learned about that in undergrad. Now I get to see it happen. But also, yeah, it's pretty fun to see that every new generation like has a totally different take on humor, which somehow is not mine, but they'll still occasionally laugh at my jokes.
In my senior seminar for the honors English program here, our faculty member, he came in like just last week and was sort of going on about the slang of Gen Z, and he said, I figured out the other day that I'm an unk. And we were like, yeah, like just generally like an older person that's like a little, yeah. And then he's like, I also heard that like he said it wrong. Originally, he goes, yeah, if you're like chalked or something. We were like, chopped? He's like, yeah, I'm chopped. We're like, ugly? Like, no, we're not going to call you ugly, but like, sure, if you want. He's like, yeah, I'm a chopped unk. We're like, okay, cool. And then for the rest of the class, he continued to sort of iterate on shocked and never actually say chopped. He was like, I'm a chot. Like he couldn't get it right. But anyway, that's
it's hard to learn new language. That's just how it is.
Yeah.
So yeah.
Can you make a Google Translate for translating slang from your generation to another?
I kind of don't feel like we should let the old people in on the young people slang. Like
wow, gatekeeper. Wow. Okay.
It's kind of nice. It's kind of amusing to watch us get it wrong. So I think we should probably keep that up. Don't make too many good tools for the old folks.
Okay, John DeNero, thank you so much for being here today. It's really been such a privilege to talk to you.
Well, I loved it, and it's great to see you, and thanks so much for inviting me. This is my first podcast, Talia, so I don't have any expectations.
This is not your first podcast. I listened to you on 2 podcasts last night.
Really?
Yes.
I won't forget about this one, the most memorable. Yeah.
Thank you. That means a lot. Thank you.
Thank you so much for listening to Tomato Tomato. I've been your host, Talia Sherman, and that was my conversation with the wonderful, the funny, the kind John DeNero, co-founder and chief scientist of Lilt and faculty director of data science undergraduate studies and associate teaching professor in the UC Berkeley Electrical Engineering and Computer Science Department. Thank you for listening. Thank you for your patience as I spent most of winter break weeping in a variety of indoor, outdoor, rural, urban, suburban, and remote locations. Go tell someone you love them. Go ask for better gun laws, fight for better gun laws, whatever works for you. And I will speak to you next time. Bye.